Hi guys, thanks for joining me today for a look at similar figures. So before we jump into similar figures though, we got to go back to another term that we need to be comfortable with so that we can do well with our similar figures, and that's proportions. So proportion is when you have two ratios that are equal to each other, and one way we write a ratio is as a fraction. So looking at this one here, 1/2 equals 4/8. You probably would agree with that. But let me turn that into a real life situation. How about you make $2 every hour, and I make $8 every 4 hours? Well, actually, if you think about it, we both make the same amount of money. Again, $2 per hour, $8 in 4 hours. Actually, if you divide the 8 by 4, you find out that's still 2. So I'm making $2 an hour. It's just a different way of writing it. So that's what we're looking for, are two ratios that are equal to each other. And that's what we call a proportion. Now, in similar figures, the similar part means is they're the same shape, but not the same size. And here you can see a few examples of that. A large and a small, large, medium, small, and so forth. So the same shape, but different sizes. But we need a quick way to check to see if these two ratios in the proportion are actually equal to each other. A couple ways to do it. One, you could see if you could simplify both ratios to the same amount. And as you can see here, this 6/9 does simplify to 2/3. But if you don't readily see that, here's another way that I like. Let me bring up let me scoot myself over here. No, not highlighters. So we'll use something that you can see. So what I'll do is I'll do what is called cross products. So I multiply up and across. So what's 3 times 6? 3 times 6 is 18. Then I multiply up and across the other way. These are again called cross products. What's 9 times 2? Well, 18. Bam. If you get the same exact answer on both sides, well, then you know that your two ratios are indeed equal, and you can call it a proportion. Make sense? Okay, well, let's keep moving on. All right, so here we have two examples. They look like they're the same shape. They're definitely different sizes, but that's okay for similar shapes. But are they exactly similar? Well, to check to see if they're similar, we want to set up one of those proportions. And here's how I like to do that. I'll take the corresponding sides here. So the 8 seems to match up with this 12 nicely if they're similar, and the 10 matches up with the 15. Okay, so that's kind of the base of these triangles. So here we go. Let's set up that proportion. All right, so if this works, so I'm going to take the 8 from this triangle, and then the corresponding side on this one is the 12. So I'm going to put that over 12. So this one over this one. And does that equal, well, this one over this one? So the base of the smaller one, 10, over the base of the larger one, 15. Okay, well, again, let's try those cross products and find out, or you can simplify the fractions either way. Well, no, let's start with cross products. So here, what's 12 times 10? Well, 12 times 10 is 120. And do you know that 8 times 15 is also 120? Here, I'll even bring up a calculator and show that to you real quick. So 8 times 15. There's the 120. All righty. So we got our 120 on both sides. That's a great way of doing that, those cross products. But here's another way. Let's look at each fraction again. Now that we know that this is a yes. Okay, we could simplify these fractions. This is another way of doing it. You don't have to do both of these, but here's another thing you could do. Can you simplify 8/12? Well, let's think. What divides into 8 and 12? Well, the biggest number I can think of is 4. So if I divide each of these numbers by 4, 8 divided by 4 is 2. 12 divided by 4 is 3. Now, okay, over here, 10 and 15. What's the biggest number that divides into both of those? Well, 5. 5 goes into 10, and 5 goes into 15. 10 divided by 5 is, well, 2. 15 divided by 5 is 3. Bam, same simplified answer. So if both of the ratios simplify to the same exact simplified fraction, they're similar. So you do have similar triangles. So there's two different ways to tackle a problem. All right, let's move on. So here, how about short side of this rectangle over short side of this rectangle? And that needs to equal long side of the little rectangle over long side of the bigger rectangle. See how I'm setting those up? So the corresponding sides over here, and then the other corresponding sides over here. Alrighty, so let's do our cross products again. 7 times 12, just to show you real quick, 7 times 12, just to speed things up, is 84. And 15 times 5, I believe that's 75. Hopefully I'm right. 15 times 5. There we go, 75. All right. Oh, definitely did not get the same answer that time. So this is a no. These are not. And now if you look at it more carefully, you can almost see that they're not the same shape. I mean, they're both rectangles, but they're not close enough in shape. This one seems, right here, the smaller one seems a little narrower for how long it is, and this one seems a little bit taller for how long it is. Hard to describe that, but they're definitely not the same exact shape. Another way of looking at it is simplify both fractions. Okay, well, does 5 over 7 simplify? No, 5 over 7 stays 5 over 7. There's nothing that divides into 5 and 7. What about 12 and 15? 3. 3 goes into both of those, so let's divide both of those by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. Oh, look at that. And they did not simplify to the same thing. So again, there's two different ways to find that answer of whether or not the two shapes are similar. Okay, hoping that's making sense. Alrighty, move myself over a little bit. So here, I'm not going to read through this whole thing carefully, but I suggest you pause the video and familiarize yourself. This is a great description that the book does on how to figure out similar figures. I'm just going to simplify. I'm going to just sort of talk about this little section right here. You know you've got two similar figures when the corresponding side lengths are proportional, kind of like we were doing with those fractions on the previous slide, and the corresponding angles are congruent. That means they have to be the same exact measure. So like see, the one little arc here matches the one little arc here, 2 arcs, 2 arcs, 3 arcs, 3 arcs. Those are symbols indicating that these angles, the corresponding angles are congruent. So when you have 3 marks here and 3 marks here, that means this angle and this angle are the same. So we have congruent angles, but then you have to work out, are your sides also proportional like we were doing on the previous slide? Okay, keep moving. Here's another example. Scoot myself over a little more so you can see it. Again, I would suggest, again, pausing the video for a few moments and really reading down through this. What you'll find out is that rectangle A and rectangle C are the two similar ones. They talk about that down here, them being proportional, and how A and B are not proportional, but they walk you through setting up each of those ratios and comparing them, and you find out that only C is similar to A. So go ahead, pause the video, check that out. And one more time, but I'll move myself over here this time. This is a lot like some of the problems we're going to do. If these two triangles are similar, then how long is X? So they set up their two ratios, they do a little bit of cross products, and they solve for the 12. But I'll let you read through that a little more carefully. We're going to do some of our own. All righty, so here we go. Are the two figures, tell whether the two figures are similar and explain our reasoning. Okay, so here we go. Now in this case, we have 1, 2, and 3 little arcs and 1, 2, and 3 little arcs. Okay, good. We're part of the way there because the angles had to be the same. But are the side lengths proportional? Okay, so let's try to set up a proportion and find out. So how about we'll take this bottom side right here. So 4 over, on the same corresponding side here, 6. You know what? I don't really need to circle these. I'm kind of messing that up. So 4 over 6. Does that equal, okay, let's pick two other sides. How about the 6 over the 9? So 6 over 9. Okay, well, let's check that proportion. We could simplify both of these fractions, and you might see that both of them simplify to 2/3. So the answer is yes. Okay, but another way is those cross products. Here's the cross product. So 6 times 6, well, that's 36. 9 times 4, that's also 36. So looking good so far. But did you notice they gave us another side over here? So let's also do one with these two sides. All right, let's give that a try. So we have the 8 over the 12. Those are two corresponding sides. Okay. And let's set that equal to, it doesn't matter which one. How about the 4 and the 6 again? Okay, there we go. So let's do our cross products. So 12 times 4, that's 48. And 6 times 8, oh, guess what? 48. Okay, there we go. So we got our cross products. We could say this is yes, definitely. And explaining our reasoning, well, the side lengths are proportional to each other, and the angles are all congruent. Bam, there we go. All right, well, if that one's a yes, I wonder if this one's a no. Well, let's find out. All right, so let's set up our proportion. How about short side of this one over short side of this one? See what I'm doing? Trying to find those corresponding sides, even though they tried to trick us by turning this one. So this short side over this short side has to equal this long side. So 9 over this one's long side, 15. Okay. Notice that both of these numbers are the numerators and both of these numbers are the denominators. You want to keep that consistent or your proportion won't work out. All righty. So here we go. 9 times 9, I know that one off the top of my head. That's 81. And guess what 6 times 15 is? Well, it's not 81. Just to save a little bit of time, we'll grab the calculator. 6 times 15, and that's 90. Well, it's close, but we're not playing horseshoes. We need it to be exact. So 90 and 81 are not the same number. So we're going to say no. They're close, but no, they are not similar. And my reasoning is you would say, hey, your side lengths, they're not proportional. The angles are congruent. They all have 90-degree angles, but the side lengths are not congruent. I'm sorry, the side lengths are not proportional. There we go. Okay, oh, now they're switching it. Now they're saying that these are similar. We just have to figure out the length of x. So here we go. So let's say, how about our short side here? And I'm going to put it over the short side here. So 6 over x. And we know it does equal, because they already said they're similar, 8 over 20. There we go. There's our proportion. Now we just have to solve. Now, how do we solve something like this? Well, there's a variety of ways, but my favorite is, again, the cross products. Just stick with what we're already doing. So 8 times x is 8x. 6 times 20, well, that's 120. Okay, so now we divide by 8, divide by 8. Now, the reason for dividing by 8 is to get this x all by itself. So now we know what x equals. How many 8s go into 120? Well, let's find out. 120 divided by 8, 15. So x equals 15. There we go. And now we could plug this back in, do the cross products, but they're both going to be equal. They're both going to equal 120. All right. So now we're over here. And now, again, we don't have to figure out whether or not, let me move myself over, whether or not they're similar. They already said they're similar. We just have to find the x value. Okay. So it looks like the 4 and the 9 are corresponding sides. So I'm going to put 4 over 9, or I could have done 9 over 4. As long as I'm consistent, it doesn't matter which way you set that up. This could have been 9 over 4, but I'm going to do 4 over 9. So little one over big one. That makes sense? And we're going to make that equal to, again, little one over big one. So x over 15. All right, cross product time. So 9 times x is 9x, and 15 times 4 is 60. Okay. Alrighty. So divide by 9 and divide by 9. And we get, grab that calculator. So again, here we did 9 times x is 9x. And then we did 15 times 4 and got that 60. And now we're dividing both sides by 9. Just going to check something real quick. So we did 4 over 9. X over 15. I just wanted to make sure I set that up correctly. Okay, so 60 divided by 9 is 6.6 repeating. So it looks like 0.6 repeating. So 6.6 repeating. Wasn't expecting that answer, but it's not necessarily wrong. So another way to write that, if we want to write that as a fraction, 0.6 repeating is 2/3. So 6 2/3. Okay, there we go. All right, so x looks like it equals 6 and 2/3. One thing to check, I'm just feeling a little uncomfortable with that answer, but let's double check. So let's check those cross products. So if I put 6 and 2/3 here, okay, so 9 times 6 and 2/3. Let me bring that calculator back up. So, oh, well, it's the 0.6 and 0.6 repeating still here. So let me multiply that by 9 and I get 60. Okay, so this cross product does equal 60. Oh, and we already know this cross product equals 60. Perfect. There we go. We've verified the answer is definitely 6 and 2/3 or 6.6 repeating. Our cross products are equal. Moving on. All right, so let's see here. Well, it looks like they turned the triangle trying to trick me into which side corresponds to the other. So let's see here. It looks like the 5 right here corresponds to the 9. Do you see if you would have turned this triangle 90 degrees, they would go together? They would correspond. So 5 over 9 does that. Oh, I'm sorry. These are already similar. So we already know they're similar. We're just trying to find x. That would have to equal 8. So again, this side over this one. And our proportion is set up. All righty. So time for some cross products. Well, 9 times 8 is 72. And 5 times x is 5x. Oh, they're giving us ones that don't divide out evenly. That's what was throwing me earlier. So we divide by 5, divide by 5. That cancels out the 5s, getting the x all by itself. Just to speed the video up a little bit, let's let the calculator handle this calculation. So 72 divided by 5 equals 14.4. Now, if we were going to check our cross products, 9 times 8, we already know that is 72. But what about 5 times, well, what did we just figure out? 14.4? Let's just check that. What's 5 times 14.4? So 14.4 times 5, does that also equal 72? Perfect. Great. All right, so here we are over here. The 9 definitely corresponds to the 21, and the 6 corresponds to the x. Okay, we've got our cross product set up. So, I'm sorry, our proportion set up. So now we do our cross products. 9 times x is 9x. 6 times 21. Let's see, 6 times 1 is 6. 6 times 20 is 120. So there we go. 9x equals 126. And again, how you get the x by itself is just to divide out the 9. This is times 9, so we divide by 9. That cancels those out, leaving us x equaling that. Again, let's bring the calculator in and let it handle that calculation for us. 126 divided by 9 equals 14. There we go. So again, 21 times 6 is 126. Is 14 times 9 the same thing? 14 times 9 is 126. Perfect. So we got our cross products to be perfectly equal. Perfect. Great. All righty. The Mexican flag is 63 inches long and 36 inches wide. Is the drawing at the right similar? So is this drawing similar? All right. So let's see. The length. So I'm going to do the length of the actual flag over the length here. So we have 63 over 11. Is that equal to 36 over 8.5? So the short side of 36 over the short side of 8.5. All right, let's bring in the calculator and get our cross products. 11 times 36. 11 times 36 is 396. Okay. And now 8.5 times 63 is 535.5. Okay, so let me just make sure I set this up right, because wow, that's way off. So 36 inches long, I'm sorry, 63 inches long, and that's the length, and here's the other length, great. So 63 over 11, great. And then the short side of the actual flag over the short side of the drawing. Oh yeah, no. So they're not similar. All right, super, moving on. A student's rectangular desk, okay, I brought a little picture of desks here, is 30 inches long and 18 inches wide. All righty. So there's our length. There's our width. A teacher's desk is similar. Okay, they're telling us it already is similar. Has a length of 50. Okay, so that would correspond to this 30 because that's how long the student desk is. So those two numbers go together. What is the width? Okay, there we go. There's our question. What is the width of the teacher's desk? Okay, so let's set up how about the first one could be this 30 over 50. Now, do you see why I picked those two? It's the length of the student desk over the length of the teacher's desk. So I got those together, the corresponding sides. Remember, we're trying to put corresponding sides together. And now the student is 18 over the width of the teacher's desk. So I'm going to just call that W. All right, there we go. Our proportion is set up. So 50 times 18, 50 times 18, 900. Okay, so we got 900 on this side. And 30 times W is, of course, 30W. All right. Oh, so we need to figure that out. So if 30W equals 900, well, we just divide by 30 like we were doing before to get the W by itself. Bam. Oh, I can do this one in my head. Who needs a calculator? Here, one little sneaky trick I do. If they both have a 0, I'm going to cross out each one of those zeros. Okay, so it's really 90 divided by 3. Guess what 90 divided by 3 is? Well, 30. And now what are we measuring in? Inches. There we go. So the width of the teacher's desk is 30 inches. All righty. Is that the last problem? Yeah, it is. So thanks for joining me today. My website's www.mattzigner.com. And if you enjoyed the video, just like, comment, subscribe before you head on out. Thanks, guys. And we'll see you next time. Bye-bye now.